Okay, here we go. Optimization problems. Optimization problems happen when we look for maximum or minimum values, okay? We're starting with one that is not very difficult. We're working with one that is a little bit more difficult, and then one that's even harder. You guys have not been shown many optimization problems. We need a little bit more content for this next test, so that's what we're doing, okay? We've done Newton's method. We've also done economics. It's time to push our brains just a little bit more. So make sure your name is at the top, and we will go from here, okay? You're going to need your calculator. It says, find the equation for the line tangent to the curve. F of x equals 2x minus 6x squared minus x to the third that has the largest slope. That has the largest slope. Let's actually graph this thing first and get an idea of what we're actually looking at. I have 2x minus 6x squared minus x to the third. I'm going to clear out my other stuff. I'm going to zoom standard. Will look something like that. From our graph, what am I trying to do in the problem? What am I trying to find? Largest slope. So you tell me, if this tangent line right here, does it have a large slope? It has a very large negative slope. So where would I have the largest positive slope? I'll draw a quick sketch here. If we have a graph, right there. Okay, Brady Falk went first. We're going to let him answer. So Brady, you tell me when I've gotten there. I would agree. That point, okay? You're right. It does happen to be the point of inflection. But before we think about the point of inflection in this scenario, we are trying to find the largest slope. So we are trying to maximize slope. Or in other words, if you're trying to maximize the slope, you're trying to maximize the... We find the slope by finding the derivative. Want to maximize the derivative. Okay? What is the derivative? Okay, if you want to maximize something, what do? You take the derivative and set it equal to 0. So if this is what we are actually trying to maximize, then we need to take the derivative of that and set it equal to 0. What is the derivative of this? Yeah. Ron, negative 12 minus 6x. So we've got 0 equals negative 12 minus 6x. Okay? So what is x? If you solve for it, we get x is negative 2. What does that tell me? What does that represent? At the x-coordinate of negative 2 is where I have the maximum slope. I need to write an equation for a line. What do I need to write an equation for a line? M and a point on the line. How will I find M? What's going to tell me the slope at that spot? The derivative evaluated at negative 2. Let's plug in negative 2 to the first derivative. 2 minus negative 24. So 2 plus 24 is 26 minus 12. 26 minus 12 is 14 is my slope. I plugged negative 2 into the first derivative. I come up with 14. Point on the line. What's the x value for the point on the line? Negative 2. How do I come up with the y value for the point on the line? The original function up here, if we plug in negative 2, you come up with positive 20. I'm sorry, negative 20. I think, let's check. I can't remember. Table, if I go negative 2, I get negative 20. So it looks like that's our point on our line. Can we now write an equation for the line? We sure can. Y equals 14x plus b. I will plug in my y value of negative 20 equals 14 times negative 2 plus b. Solve, and you will get negative 20 equals negative 28 plus b. So b is equal to 8. So the equation for this line that has the largest slope is going to be y equals what? 14x plus 8. If we were to type that into our calculator, you would see that they are, in fact, that it is tangent, and that would appear to be the largest slope. Inflection points would be the second derivative set equal to 0, which is what we did. This does both match the inflection. The inflection point is where it does have the largest slope. Common occurrence. If I asked you a question like that, could you do it again? Excellent. Let's try a more difficult one. Hey, who said probably not? You can do it. You can do it. All right. Let's stretch our brains a little bit, something a little bit more difficult, okay? This is good stuff right here. You guys are going to like this, okay? Find the equation for the line, similar type of problem, but that goes through the point 4,2, that cuts off a triangle from the first quadrant with the largest area. I read this problem last night, and I was so excited I lost sleep over it. 4 minutes, so. you guys are a bunch of jerks. That's what you are. Okay, so we have this line, and it goes through this point 4,2, and it cuts off a piece of the circle, right? I'm sorry, it cuts off a piece of this quadrant, and it gives us a triangle. Now, just for this problem, in order to kind of help us understand, what I'm going to do is I'm going to call this A, point A. This is going to be an important spot, I think. I'm going to call this point B. So how do you figure out the area of a triangle? Okay, so area would equal 1/2 base times height. So what is the base in this scenario? Length B. And what is the height? A. So what we really need to do is write an expression for B and A. And if we write an expression for B and A, then we can multiply them together. So tell me something interesting about A. What does A represent? The height. What does A represent for the line? The y-intercept. So A represents the y-intercept of the line, and the y-intercept has an x value equal to x equals 0, okay? B represents the x-intercept, where y is equal to 0. So I need an equation for the line. I'm going to turn to point slope form. Y minus y sub 1 equals m times x minus x sub 1. And that's going to serve as the equation for my line. So that's my equation for my line. I can substitute in 4 and 2. True or false? I know m. I don't. I have no idea. I have no idea what m is. Isn't that kind of what I'm trying to find? If I knew m, then I could write the equation for the line. So m is what we're eventually going to be solving for, but let's start by this. Let's actually find the y-intercept. The y-intercept occurs where x is equal to. So I'm going to plug in everything that I can. Y minus, what is y sub 1? 2 equals m times, x is 0, right? And 0 minus 4 would be negative 4. So if we solve for this, okay, the y-intercept is equal to negative 4m plus 2. Agreed? That's the y-intercept. Now it's time to find the x-intercept. In order to find the x-intercept, I plug in 0, 4, y. So if you look at your whole formula here, we have y minus 2 equals m times x minus 4. And what we want to do is plug in 0 for y. So negative 2 equals m times x minus 4m, right? What do I want to solve for? X, because that represents my x-intercept, so I should add 4m to both sides. I get 4m minus 2 is equal to mx. Divide by m, and I get 4 minus 2 over m is equal to x. I'm going to choose to write it like that. 4 minus 2 over m. Yes? Okay, so 4 minus 2 over m is x. Let's pause and reflect really quick. This problem, the line goes through 4, 2. I'm cutting off a triangle. I want to maximize, or cuts off the largest area. Oh, it should be smallest. It would be infinity. Yeah, you're right. You're right. So smallest area. Okay. Sorry. Wrote the problem wrong. So here's what we have. We have this triangle. We're trying to cut off the smallest area possible. And so what I did is I wrote an equation for area, 1/2 base times height. And we found the base represented by the line. It would be 4 minus 2 over m. And a would be negative 4m plus 2. So all depends on the slope of this line, right? So we have two expressions that each have m. Let's plug it in our formula and go to work, okay? Area equals 1/2 times a, and a is negative 4m plus 2, times b, which is 4 minus 2 over m. I've written an expression for my area. Now what? Boil it all out. Yep, let's boil it all out. I'll do the 1/2 later. Area equals 1/2 times negative 4m times 4 is 16m. Negative 4m times negative 2 over m. Positive 8. 2 times 4? 8. And 2 times negative 2 over m? Minus 4 over m. So area is equal to, we'll multiply through by 1/2. 1/2 of negative 16m is 8m. 1/2 of 16 is negative 8m. I'm sorry, thank you. 1/2 of 8 plus 8 is 8. And 1/2 of 4 over m is that's the expression for my area given a certain slope. I want to minimize that. How do I minimize something? Take the derivative and set it equal to 0. So a prime is equal to, what's the derivative of negative 8m? Negative 8. What's the derivative of 8? 0. What's the derivative of negative 2 over m? No, we don't have to do the quotient rule. Remember that this can be expressed right here as negative 2 times m to the negative 1. What's the derivative of that? 2 over m squared. Very good. Derivative of that is 2 over m squared. We should set that equal to. Solve for m squared. What do I do to both sides? Add 8. 2 over m squared equals 8. Cross multiply, solve. 8m squared equals 2. Divide by 8. M squared equals 1/4. So m is 1/2. Positive 1/2 or negative 1/2? Look at my slope. M should be negative 1/2. So I come up with two solutions, positive 1/2 or negative 1/2. I need the negative 1/2 because the slope is negative 1/2. Do we have everything we need to write the equation for the line? We sure do. Let's write it. Yes. I hear some enthusiasm here. This is great. Okay, for this line, m is equal to negative 1/2. So all I need to do is, I'm running out of room, so we'll go over here. Red and green. So we have our point on our line is 2, 4, or 4, 2. What is it? 4, 2. And our m is negative 1/2. So y equals m times x plus b. 2 equals negative 2 plus b. 4 is equal to b. Y equals negative 1/2 x plus 4. Isn't that awesome? It's great. Cut it off. Look at the problem from the beginning, you guys. Look at that. Find the equation of the line. That's algebra. Cuts off the triangle. That's geometry. Smallest area. That's differential calculus. We minimized it. Kyle says, when am I ever going to use this, right? When you get to this next problem. Because yep. Because this one here, and you guys, there's an infinite number of optimization problems. I can't possibly expose them to you all, but we needed to try a couple that are a little bit more difficult than what we tried the other day. Now I'm going to give you an assignment that asks you to duplicate these problems. You can follow along with your notes, but I want you to be familiar a little bit with this process because I know you know how to take the derivative and set it equal to 0, but some of the setup with the geometry and everything, that's a little bit more difficult. So Kyle someday is going to build his own gutters. He's going to take a piece of tin that's 24 centimeters wide, and then he's going to fold it to create a gutter with a base of 10 and sides that are 7 centimeters both. Okay? So here's what he's doing. He's taking this piece of tin, which is 24 centimeters in length, and he's going to fold the sides up. And he's going to fold the sides up such that this angle right here will be the same for both of them. What he wants to do is he wants to maximize the amount of water because he knows he's going to have a lot of rain coming this spring. He needs to maximize that gutter volume so that it gets rid of the most amount of water. He doesn't want it going over the sides. Right, Kyle? This is what you're going to use, right? my basement flooded last year. If you would have known this, we could have saved your basement. Oh, next time you walk outside, you see some gutters. You're going to tell the homeowner, you say, I could help you with those. I could help you with those. I could maximize the volume. So let's do it. Let's do it. Okay. If we want to maximize that, we would be maximizing the area, right? What shape is that? It is a trapezoid. This is where the entire problem is, and this is what you guys gotta follow. After this, it still gets bad, but it's really at the beginning that we have to follow. So this is a trapezoid. What's the area of a trapezoid? 1/2 times the height times the sum of the bases. Very good, everybody. Really what this is, everybody, is it's the average of the bases. 1/2 times the sum of the bases gives you the average of the bases times the height. That's what that does. What? Someday she'll be watching this, yes. Okay. So how's Morgan feeling about it right now, do you think? Morgan, you can fast forward through this part if you want. Um, so let's get through this, okay? So let's see what we have. No. We need expressions for the base and the height. Now, I have one of the bases, right? It's 10. But I don't have the other bases, and I don't have the height. So I need a little bit more space. I'm going to insert a page here, and I need a little bit bigger trapezoid to kind of draw this. You don't have to draw it, but this is I want to do this to make sure that I help you, okay? Okay. When you encounter problems in geometry, which you're folding something, they're an angle, we really do need to turn to trigonometry. And this is a problem with trig that turns out really, really well. This works out just beautiful. Now, as I make this shape, I can fill in some pieces here. What is this piece right here? 10. Very good, Taylor Blake. Now, I'm going to call this X, and I'm going to call this Y. Now, note that we want to be able to fold up an angle, okay? We want to be able to fold up this angle right there. But in terms of the triangle, I'm not really concerned about that piece right now. I'm concerned about this angle right there, okay? And so what I can do is instead of having X and Y using trigonometry, I can write everything in terms of one variable, which would be theta. And that's going to be really helpful. So basic trigonometry. You tell me, okay? I have theta, I have 7 on the hypotenuse, I have y on the adjacent. Sine, cosine, or tangent? Cosine. Cosine of theta is equal to the adjacent side, which is 7, divided by, or I'm sorry, the adjacent side, which is y, divided by the hypotenuse, which is, right. So if I want to solve for y, what would y be equal to? 7 cosine of theta. That's my height. My height is 7 cosine of theta. Now I need this portion here. I need x. Well, x has to do with the opposite side, so I'm going to use sine. Namely, that sine of theta is equal to x over 7. If you solve for x, you would get x is what? 7 sine of theta. Okay? And so this piece here is also x equals 7 sine of theta. So, what is my lower base? What is my height? 7 cosine of theta. What is my top base? 14 sine of theta plus 10. Yep. We've got all our pieces, and how many variables? 1. Yes, it's easy. Very good. All right. It's not. We can do this. We are super smart. 1/2 times, what was our height? 7 cosine of theta. What was that lower base? 10. This is the magic, you guys. We just wrote a formula for the area in terms of theta. I mean, after that, all it is algebra and differential calculus, which we know how to do. The geometry and trig setup, the geometry and trig setup is really the hard part. So now, no more pictures. All we have to do is just focus on this piece, and it's really not that bad. Okay? What's that? Well, because base 1 plus base 2. So let's simplify this. Okay, 1/2 times 7 is 3.5 cosine of theta times 20 plus 14 sine of theta. So at this point, I could either use the product rule, or I could distribute and then just use the regular power rule. So let's distribute. I get 3.5 times 20 would be 70. 70 cosine of theta plus 42, 49. 49. Look at that. Let's take the derivative of it. Do you remember what the derivative of cosine is? Negative sine. Negative 70 sine of theta plus, yes, thank you, product rule. Okay, what's the derivative of 49 sine of theta? 49 cosine of theta times cosine left alone, 49 cosine squared. Plus, what's the derivative of cosine? Negative sine times 49 sine would be negative 49 sine squared. Got a cosine squared. That's a problem, right? Well, I mean, because these are, you got sine and cosine. These are different pieces. No, we're not. Oh no, no, we're not okay with it. This is problematic. You got to get rid of cosine squared. Do you know what cosine squared is equal to? Very good. Good job. So we got negative 70 sine of theta plus, if I distribute the 49 through this piece, I get 49 minus 49 sine squared. So I'm substituting the 1 minus sine squared in it. I got to distribute the 49 through that then, obviously. Minus 49 sine squared. And so now let's just combine like terms. Let's focus on our sine squareds. Negative 49 sine squared, negative 49 sine squared would be negative 98 sine squared. What will be my middle term? Look, minus 70 sine. And then I have 49 on the end, right? Okay, so the geometry at the beginning, the hard part. We saw the trigonometry where you have to put in the 1 minus sine squared, but overall we've really just been doing algebra at this point. Now, we are this close to the solution. We're not going to factor this. We're not going to factor this because once you get to this point, why do any unnecessary algebra? This is a quadratic, is it not? Yes, you could, but we're not going to. You cannot. 49 is not. So I get a sine squared. I have a sine to the first, and I have nothing over here. So I can use the quadratic formula at this point by a very simple substitution. Instead of solving for x, I will solve for sine of theta. So can you take out your graphing calculators? Can you guys figure out what are my two answers that I get for this if I plug in negative 98, negative 70, and 49? What do I get? What do I get? I need to 4 decimal places. And? Okay. Sine takes on values between what two numbers? Negative 1 and 1. Very good. This is outside of the this is outside of the range of sine of theta. This does not, this is a bogus solution, but can sine take on a value of 0.4350? Yeah, how do I figure that out on my calculator? How do I figure that out? I want to work in degrees, not radians. So if I go to my degrees, I want to solve for that angle. How do I do it? What do you do? Sine inverse. Sine inverse of 0.4350, and you get 25.78, 25.79. Now, if you go back to the original problem, if you look at what we solved for, actually, you guys, we found theta right here is 25.79. We actually want this measurement right here. And so that measurement, how do we find that? From 90, which would be 64.21 degrees. So, gutter man, if you would take your gutter and fold it at 7 and 7 at an angle of 64.21 degrees, you will maximize the amount of volume that the water could take. You wouldn't make that big of a difference, but it would make a difference. This is optimal. That would require the whole next tomorrow. So, okay. I don't know. Hey, good job. You guys, here. Hey, hold on, guys. Hey, first problem. First problem, you can do that, right? Second problem, little trickier, but capable. Third problem can stretch your mind. You guys, you know how I prepare you for stuff. You know, that third problem, you know, maybe kind of the extra credit type piece, but I want you to see a problem like that, okay? Good job.